So, no ghosts. There's always a ghost in here. This is the ghost of my smartboard. Do you notice anything different?
It's brighter.
I got my light bulb. Yes, that's much brighter. It doesn't stop all my other issues, but at least it's nice and bright now. Yes. Okay, so the first one, you just had to find your margin of error and create a confidence interval.
Yes.
You guys tell me if you have any problems. Can you do this on the calculator? No. No? Or yes? Yes. And when you make your confidence interval on the calculator, just take your mean and subtract your mean from the upper end. And then this will give you your margin of error. So all you have to do is this part right here. And you can bypass not using your formula. Okay, and I use formulas just in case anybody uses them. But the confidence intervals, the reason I like them so much on the calculator is because it actually says the word interval. You don't have to think about which one am I supposed to use. It uses the word interval. This one, yes, has a Z. And by the time you hit the next little section, you'll see why it says Z versus T. And then you'll see the one with the proportion. So it does kind of make sense when we do this. Okay, number 23. Again, you're finding your confidence interval from your margin of error. This is your wiggle room, your plus or minus. I'm kind of hoping that those articles give you a better understanding for margin of error, how it works on your interval. 25 was a good one. 25 is the end brackets. These are the end brackets of your interval. Your mean has to sit smack in the middle, so that's your average. Add them up, divide by 2. Then take the distance to either endpoint. That's your margin of error. The same as if you used your calculator. Question? We didn't do 25?
No, we only did 29.
Oh, okay.
We did 25 for one of the other.
We did 25 before. Okay, we did 25 the last time. That's right. Sorry about that. We did 25 the last one. So 29, again, this is just using your formula. This one is not in your calculator. And yes, I will give you this formula. I will give you this formula, but you have to know how to find your ZC, your Z-score associated with that level of confidence. Then you're going to find your standard deviation, your margin of error. This time obviously it's not words, but it usually will say within something. And remember, always, always round up. We're seeing how many people we need in our sample. We have to have a whole number. If we cut it down to 125, we never hit 125.1. So that's why we always round up. And again, I did out the ZC. Remember, put 80 in the middle, subtract it from 1, divided by 2, do an inverse norm. Remember to square the whole thing and round up. Not a lot to confidence intervals. Once you get a little bit adjusted to them, it's a little bit different because we've been doing your probability statements, we've been sketching your mean, your standard deviation. This one is a different type of animal here.
So do you want us to round the 0.9, like once you plug that into your calculator and get your like Z-score or whatever? Or, like,
The Z-scores always go to 2 decimals.
You always want point.
Oh, always I want 2 decimals. The only Z-scores
you got 125 and I got 124. And like you round to 126, I round.
Well, that's what I was going to say. The only Z-scores that we use that we round to 3 are the 1.645 and the 2.575 because they fell smack in between 2 of their entries. However, but remember, like when we were doing this, I said if you round this to 164, just show it to me.
Okay.
Show it to me, and I'm fine with that.
Alright.
But just follow your regular rules. Make sure you round up at the end. I use the 1.645 and the 2.575. If you don't, because you're looking it up on your calculator, and you say, which one am I supposed to have 3? Just make it a 2, and I will be fine with that. I just use that because I know that those are the ones that have 3. But you are absolutely fine with that. Okay? Now they just put it into words. Same thing as we were doing in number 25. They gave us this confidence interval, and they wanted to know the margin of error and the sample mean. Do the sample mean first, that's the one in the middle, and then divide it by 2 and subtract it from an endpoint. Are we good with this? Questions at all? Yeah, not a lot of work. Once you get past the original, like what the heck is this thing, it's really not a lot of work. The ones that we look a lot at are changing your confidence level. Remember, if you want to be more confident that your population mean is going to fall between those two numbers that you found, you want to have as much wiggle room as possible. So therefore, the more confident you are, the wider your interval is. Not bigger, wider. And less confident, a little narrower. And what's nice about this is, if you use your calculator, it kind of gives it to you real fast. You don't have to recalculate all these things. Also, we looked at what happens when we increase your level of confidence. When we increase your level of confidence, what happens to your sample size? So we look at those two things. Are we okay with this? And we're going to use the words wider and narrower. Is narrower a word? Narrower. Okay? You randomly select 50 of these guys and you find their mean. Because you randomly select 50 and you find their mean, this is your sample mean. And the population standard deviation, you don't use your sample standard deviation, just your population standard deviation. Again, you could go right to your calculator, do this, and subtract it. Now, if you like to write it like this helps us in our interpretation. Now, your interpretation is really, really important, because what you're saying is you're going to be 95% confident. We talked about this the other day, that the population mean of replacing a car's transmission is between these two numbers. Oops. Okay, is between those two numbers. Write that down, because you have to be able to tell me how you interpret this. You're going to go back to your state, your problem. So you're going to tell me that you're 95% confident that your population mean, not your mean, not your sample mean. We know your sample mean falls in between there. You put your sample mean there. So we're making an inference about your population. Okay, so we want to be 95% confident that the mean of the cost of replacing a transmission for all transmissions falls between these two numbers, $2,532.20 and $2,767.80. Okay? I figured once we get them out of here, we can kind of talk about them a little bit more. 38. In a random sample of 60 refrigerators, there was their mean. That's a sample mean. And they give you the population mean. Construct a 99% confidence interval for the population mean repair cost. So now you're going to be 99% confident that the mean repair cost for the population will fall between those two numbers. You made an inference about the population because it was impossible for you to find every refrigerator in the United States repair cost and calculate it for every refrigerator. So you sampled 60 of them. and you found a confidence interval. You found a little bit more off the sample to give you a little wiggle room. The problem with picking one number is very, very slim. Getting in between two numbers is a lot better. So everybody can do this? Okay. 45 just had you enter it in your L1. And for those of you that use your calculator, when you go to stat test and you go to your Z interval part, and you saw it said stat or data, said data or stat, something like this. This is where you put this on, and you'll see your L1 table pop up. If that's the case, it's just going to take your information right from your L1 table. It's going to do the one-var stat for you. So you don't have to do that. In other words, when you pull up your calculator, oops. When you come here, when you're on data, this is going to tell it, you're going to put your population standard deviation in. There's your population standard deviation. But you're going to tell it, I put my data in L1. So now, you don't have to go to your data and do a one-var stat. You let your calculator do it. You put it in, you put this in. I don't know if I have anything in my L1. I must have. This is not this problem though. But look what it does. It shows you your mean. It tells you your N. You don't really care about your sample standard deviation, but it tells you this part, and it gives you your interval. So you don't have to recalculate that yourself if you use your calculators, for your stat test. If not, you have to put it in your one-var stat, L1, get your mean, not your standard deviation. You're going to use your population standard deviation. Good? And again, we could see if we want to be more confident, we need a wider. Now, usually what happens is, you really can't tell much from this. If you start like this and put your mean here, so your mean is 24.1. So if you do this, 22.5, 25.7, you just make them equally spaced apart. Now, where do I put 21.6? To the left of this, right? 21.6 to 26.6. Do you see it wider now? You really can't tell when you look at just your two numbers. So if you just put it on the number line, you don't have to put any tick marks on it. Just start with your mean, go evenly apart, and then just figure it out. Is it inside? Is it outside? And you'll get a better feel for it. I think we're almost done. And this is no. Okay, minimum sample size again. Remember to round up. When they say within 1 unit, this is what you want to watch for. This is your margin of error. And remember, don't put 0.95 in here. Put the z-score that is associated with that confidence interval. And the last one, this is the last one. Oh, it's 38. Oh, this was the last one. Okay. So you want to estimate the mean within 1 year of the population mean. So within 1 year of the age thing, the mean. So this is a year this represents. Assume that they're normally distributed. You determined your minimum sample size, which is not very large. They want you to change it. So if you want to be more confident, put a few more people in your sample. You have to be careful with your sample, because remember, if your sample is not a good representation of your population, you're not going to know that, because you did everything randomly, unless you didn't do it randomly. But if you do everything randomly, you're still not going to know that it is a good representation. So that's what's important in this. So if you want to be more confident, a few more people, usually a lot more than this. And just make your sample a little bit larger. Same thing with your confidence interval, a little bit a little wider, if you want to be more confident. Either way, you still have to round up. Always round up on your sample size.